collision model is the model built around the idea that molecules must collide to react. So does every collision cause a reaction? The kinetic energy that molecules have when they're moving is going to be converted to potential energy as bonds are broken and new bonds are formed. In order to break these bonds, we have to have a certain amount of energy. That energy was activation energy. So looking at this energy diagram, we have reactants and we have products. To get from reactants to products, we're going to have to go and overcome activation energy. When we're at the top of the hill, we're at a transition state where it's not reactants, it's not products. If we have enough energy, they go on to become products. If they don't have enough energy, they go back down to become reactants. Molecules also have to collide in a particular way in order to produce an effective collision. If we look at this picture, we need the bromines to hit each other. When they hit each other, then my NOs would be formed. So this one, I have my BRs hitting each other and I form my NOs. But if the oxygens hit each other, then no reaction occurs. So of these three orientations, only two of the orientations would have resulted in an effective collision. So for an effective collision, two things have to take place. You must cite both of these reasons when saying will a reaction speed up or will a reaction take place. These are the two things we should be thinking about. Is one, do the collisions have enough energy to overcome activation energy? If not, the reaction's not going to take place. And will the orientation of the reactants allow for the formation of new bonds? So when they collide, will they collide in the right orientation? The more times they collide, the greater the chance they're going to collide in this correct orientation. So here are some different ways that you can increase the rate of a reaction. When you stir your reactants, we're not affecting activation energy, so it has no effect. But when you stir, you're going to hit the molecules and you're going to push them closer to each other, so you're going to have more collisions. If you increase the temperature, the molecules are going to be moving faster, so more of them are going to reach that required activation energy. They also collide more often, and if they collide more often, there's a greater chance they collide in the right orientation. Go ahead and pause the video and figure out if you think it affects activation energy, orientation, both, or neither for the rest of these. Restart when you have the next four done. So when you add a catalyst should affect activation energy, because the definition of a catalyst is it provides an alternate pathway with a lower activation energy. But it's not going to have an effect on collision orientation, because it's not going to provide more collisions. If you increase the surface area, it doesn't affect activation energy because it's not changing activation energy and the molecules aren't going to move faster, but they will collide more often because there's more area exposed to the liquid or whatever is reacting. If it's in a smaller container, then our activation energy is not going to be affected. We're not changing how fast the molecules are moving, and we're not changing activation energy. But if they're in a smaller space, they should collide more often. So greater chance they're going to collide in the right orientation. And if I increase the concentration of reactants, again, I'm not changing activation energy, but if I have more reactants, they should collide more often. So down at the bottom, it says a small increase in temperature causes a large increase in reaction rate. If you had to explain this problem, you would say, okay, well, temperature, we just said affects activation and number of collisions, which affects your orientation. So you would need to cite both of those things in your answer. So the full answer you would need would be this. The molecules would have more kinetic energy, so they collide with more energy. Thus, more molecules have the required activation energy. The molecules also collide more frequently, therefore there will be a greater chance that the molecules will collide in the correct orientation for a reaction to occur. Notice I'm citing both things, activation energy and frequency of collisions, which affects your correct orientation. Increasing concentration only affects orientation. So my complete answer for that one would be a higher concentration will allow the reactants to collide more often. This means there will be more chances for the molecules colliding in the correct orientation to allow for the reaction to occur. Go ahead and pause the video and make sure that you write the full responses that I have here on your paper, and then that's the end of the video.